We mentioned that blood enters through the main artery, known as the cavernosal artery, which branches into helicine arteries. These smaller arteries fill the cavities with blood, which then exits through the subtunical venous plexus and flows into the emissary veins, which you see as the connecting link. These are the main ones responsible for the veno-occlusive mechanism. How? The emissary veins, as we said, are the ones that transport blood from inside the cavernous body to outside the cavernous body. Why? Because they penetrate the wall of the cavernous body. Now pay attention. As they penetrate the wall of the cavernous body, which is essentially composed of two layers, an inner circular fibrous layer and an outer longitudinal fibrous layer. Each vein is filled with blood inside the wall of the cavernous body. But when we start to see it outside, how it actually exists, that's where the marvel lies, and that's what's responsible for the vaso-occlusive mechanism. This is what will help you understand what venous leakage means. Let's concentrate here. When the vein exits the corpora cavernosa, it starts penetrating its wall to exit. Does it penetrate directly to exit outward? Actually, no. The vein penetrates through the first layer of the tunica albuginea, then it travels obliquely. This means it moves horizontally a bit and exits from another point, different from where it entered. There's a distinct entry and exit point. They're not directly opposite each other. It enters from one point, travels obliquely between the layers, and then exits from another point. The next vein enters from a different point, travels obliquely, and exits from another distant point. This pattern repeats across thousands of emissary veins that circulate and transport blood out of the corpora cavernosa. These veins are very fine, resembling hair strands under a microscope, circulating blood out of the cavernosa. Each one doesn't exit directly. Instead, it enters from one point, travels obliquely, and exits from another point. What is the idea behind this mechanism? The idea is that as long as the penis is flaccid, the layers of the corpora cavernosa are apart from each other. This allows blood to enter and exit normally, smoothly, quietly, and peacefully. That was the flaccid penis. Let's see what happens during erection. When smooth muscle relaxation occurs, blood enters in large quantities. The artery pumps a large amount of blood into the cavities within the erectile tissue, which become filled with blood. The pressure inside the corpora cavernosa begins to rise. Imagine with me that within this cavity there's a wall which consists of two layers. As the pressure inside rises, what's the first thing that happens? The two layers adhere to each other. The inner layer is compressed due to the pressure sticking to the outer layer. When these two layers adhere to each other, what happens next? All the veins running obliquely between the layers suddenly close off. This is the veno-occlusive mechanism. As soon as tumescence begins, the pressure inside the corpora cavernosa starts to rise. Suddenly, the inner wall of the corpora cavernosa adheres to the outer wall and closes off thousands of emissary veins running between the layers. What happens when the blood outside stops? As the pressure inside the corpora cavernosa increases, this closure intensifies. The higher the pressure, the tighter the closure of these veins, and the more pressure on the walls increases. As the pressure inside rises, it presses the layers together more tightly, further closing off the veins. From here, it becomes clear that erection is a closed loop. As long as there is an erection, the veins remain closed. Why? Because of the high pressure inside the corpora cavernosa, which causes the walls and layers to stick together. Therefore, all the veins are sealed shut. The blood can't exit, and as long as the blood can't exit, the pressure remains high, sustaining the erection. Thus, the closed loop continues for the duration of the erection, whether it lasts 5 minutes, 10 minutes, 15 minutes, half an hour, until ejaculation occurs. When ejaculation occurs, what happens? The sympathetic supply becomes active, stimulating smooth muscles in the arteries that supply blood to the penis. These muscles constrict the arteries, reducing the blood flow into the penis suddenly. As a result, the pressure inside the penis and corpora cavernosa decreases. What happens next? The two layers of tunica albuginea that were stuck together start to separate. Thousands of emissary veins, which are tiny veins running between these layers, suddenly open up. This results in relaxation, so this is veno-occlusive mechanism. It is a result of the emissary veins, which are thin veins running obliquely between the layers of the tunica albuginea of the corpora cavernosa. These veins get compressed between the layers and are closed off. When ejaculation occurs, causing relaxation, these veins open up as the pressure decreases, leads to flaccidity as they allow blood to flow out freely. This is the main mechanism. So what is venous leakage? Venous leakage is when 1 or 2 or even 10 of these veins do not close properly for one reason or another. It could be due to minor damage in a specific part of the penis, resulting from injury or a lack of tissue elasticity. So what happens? 1, 2, or 3 veins in a particular area fail to close properly. What results from this? The blood starts to leak out from these veins. So what happens when the blood leaks from these veins? It results in insufficient increase in pressure within the corpus cavernosum. When the pressure doesn't rise adequately, it leads to the layers not sealing tightly together. When the layers don't seal tightly together, what happens? The remaining thousands of veins that are essentially intact will leak. Why? Because the walls are not tightly sealed together. This is why treating venous leakage is challenging. Someone might suggest, why not treat the leaking vein? How would you identify it? It's just one among tens of thousands of delicate veins surrounding the corpus cavernosum that begin leaking blood on their own or alongside 3 or 4 others. As a result, the pressure within the corpus cavernosa doesn't rise sufficiently, and the layers fail to seal tightly together, causing the remaining veins to leak. Only 1 or 2 leaks resulting in 1,000 other veins leakage. So what happens? The patient might say, I get an erection, but the organ doesn't stay firm enough because the blood pressure inside doesn't increase. It's the same concept as we mentioned. It's like a balloon with a hole where some of the air escapes, so the pressure doesn't increase. The same story applies here. The corpus cavernosum fills with blood, but part of it leaks out. Therefore, the blood pressure inside the corpus cavernosum doesn't increase sufficiently, causing the rigidity to become weak. This is venous leakage.